Good morning, everybody. Okay, reInvent, day 3, Wednesdays, 11:30, almost the afternoon. We're going to do a quick intro. But before we do a quick intro, I was talking with Dan earlier. It's like, hey, we need to know the audience as well. And I talked with Dan, I think there's two types of audience in the room. One would be platform engineer, platform developers, platform teams. If you are platform, raise your hand. Can see you. Great. Nice to meet you all. Developers as well, because we believe there's a developers in the room. But let's check our theory. Any developers in the room? There we go. Yes, we do see a couple developers as well. And I believe you all come to these sessions because you believe that self-service infrastructures is no longer a dream. So I believe you are on the right place. My name is Wei Xiao. I'm a principal partner solution architect here at AWS. And I'm joined with my colleagues, Dan.
Hi, I'm Dan Barr. I'm a technical product marketing manager with HashiCorp.
All right, so we'll get started. I'm going to start the presentation with myself. Here's a quick look at of the agenda. We have so much to cover today. We're going to address why self-service is important, because you all already know, and some of the challenges with the self-service as well. And then we're going to talk about Terraform Cloud, the Terraform module developments, some of the tricks you can use in here, the developer experience related to the self-service, and also we have a demo. Lastly, if we still have the time, we're going to open up for Q&A. If we don't have the time, we're going to meet you all in the hallway as well. We can talk more about the self-service infrastructures. Now, before I get started, I'd like to take this opportunity to really celebrate the collaborations between HashiCorp and AWS. I had a lot of privilege to be part of this journey as well. You can see in here, the Terraform providers has amassed more than $2 billion. HashiCorp won the Security Partner of the Year on 2022. They are also the top 10 of the DevOps partner in Marketplace. And there are so many engineering efforts, as you can see in here, such as the AWS and AWS CC cloud provider, the Service Catalog integration with Terraform Cloud, and also the account factory for Terraform. And one last thing. HashiCorp just won the Partner Collaborations Award on 2023. So there's so much collaboration in here. I'm so excited with that. So earlier I mentioned there's two types of the audience in the room. The platform team, you're really, really good at what you're doing. That's why so many people are looking for you, because you're really good at defining infrastructures in Terraform, in CloudFormations, in CDK. You know all of these security guardrails that need to be implemented. And because of that, so many people come to you asking, hey, Welly, where is this EC2 instance? I need these new accounts to be proficient. I need this cluster to be proficient, and etc. And you're looking for all of these emails that are coming in, Slack messages, ticketing, like, hey, how do I scale myself? I'm not happy because I couldn't learn about the new things that just come up at reInvent. And in the same pace, the developers, you really want to focus on your applications. You might just get up from the keynotes. You might saw the announcements about Bedrock a couple hours ago. And said to myself, like, hey, where is that EC2 instance that I requested 2 days ago? It's not there yet. And really, it's emphasizing the importance of the self-service itself. The survey from HashiCorp shows that 92% of the organizations, they really rely on the platform teams. So platform teams, be proud, you are the enabler for your organizations to operate and then utilize the cloud. Now, at the same time, the skill shortage still remain to be the #1 blocker. And this skill shortage itself varies from organization to organizations, but typically this will become the problems when you look at how you can scaling your team, scaling your organizations, and enabling their self-service. So we believe that for you to scale the platform team itself, it means you enabling the self-service. This quote from one of our customers really speaks for itself, in my opinion. They say, like, when you want to create this decentralized self-service model, first, you want to have that very strong platform team that can teach, that can train others in the organizations. And I believe there's addition to that. not only you need the strong platform teams, you also need to have a strong developers that become the advocates for the platform team. Because they are the one who are going to tell their colleagues, like, hey, I just used this self-service model. It works very well. I can get my stuff done. And then you should try it, for example. So cross-pollinizations between your users or your developers is also very important. Well, if this is easy, why we have this session to begin with, right? Self-service comes with its own challenge. Myself and Dan and a lot of our colleagues, we've been talking a lot with the customers throughout the years, and we're going to share some of those challenges and see if that resonates with you all. That said, we also want to hear if there's other challenges that you have, and maybe we can talk more about it in the Q&A sessions. Okay, first, security. It's always day one here in AWS, same thing with HashiCorp as well. And then there's always this tension between self-service and the least privilege model. You want to enable your developers. Does that mean they have full access to the accounts? And then if not, then how you actually package all of these components to allow them to utilize it. Then there's also the frictions, which can lead to the frustration itself. The skill to use infrastructure as code, it has a low barrier to entry. But to actually configure your infrastructure correctly, making sure you apply all of the guardrails and everything else, can be a complex things to instrument as well. And if you don't package those self-service in the right way, it can create some friction for your developers as the end users. Why? For example, if I'm a platform team, I give to my developers, here's the repo, here's the CI/CD pipelines, go ahead, start writing your Terraform code. And you might have the developers who really like that, or you might also have developers that, what is Terraform? I have to learn now. Now I have to write these Terraform configurations, push it to the pipelines. There might be some errors. And depending on how you package that CI/CD pipelines, the developer might have to go to you as the platform, hey, Wally, what is that error? I don't understand. How do you fix this? Then you go back and forth into this whole cycle. Right? You think you have a great system, but you're actually introducing a lot of frictions. And lastly, you want to unlock this operational efficiency. The platform team has to scale with that adoptions. If you have 100 users, if you have 1,000 users, it doesn't mean like it's a ratio that keeps growing. Like, I believe most of the time we see a platform teams that like 2 or 3 persons. And the question is that how you can focus your expertise and then externalize it to your end users, which is the developer itself. So what is our guiding principle to address these challenges? Again, we learn a lot from our customers, and here's some of key takeaways. When you talk about self-service, it's a balancing act. It's about how much opinion you want to bake in. For example, how you want to create the versions, how that version will be updated. It's also about defining guardrails, security guardrails, costs. And when you're defining those guardrails as well, you have to think about reliability, availability, maintainability, and also safety. And lastly, for the platform team, know your customers. Have a product-oriented vision about your platform. You have to build something that your customers, which is your developers, like to use. You need to understand where they are in their journey, what are their requirements. Do they need EKS cluster? Do they need ECS? Did they learn about something new with Lambda? Should we enable them to use Lambda, for example? And then think about that whole developer experience, removing the frictions and adding the value as well. So the path to self-service. I believe there's a couple of components in here. We can always discuss like adding additional components, but first about improving the security, least privilege, eliminate the static credential, for example, and enforcing the guardrails. Next is about reducing the frictions, how you can codify this best practice that you have as the platform and externalize it to your end users. This is about producing reliable modules. If your Terraform modules is flaky because one small changes in parameters, you can just make a cascading error, for example, how you can catch that earlier during the development of that module, not when you providing it to the customers. And it's also about gaining that efficiency by externalizing yourself. I keep saying this, is that make that self-service scale. And this is where some of the Terraform technology in here, such as Terraform Cloud projects, dynamic provider credentials, policy as code, and also like private registry, the condition and checks, and the Terraform tests, which come up at Terraform 1.6. And then we're also going to talk a little bit more about no-code provisionings, the Waypoint templates, and Service Catalog. And with that, I'm going to hand it over to Dan. He's going to share his thought about this self-service in Terraform Cloud.
Great. Thanks, Wally. So again, if you're here, you're probably experiencing some of these challenges. Hopefully they do resonate with you. So let's talk about solutions now, how Terraform can help you solve these challenges, and in particular, how Terraform Cloud can help with these challenges. Wally listed off a number of features that we have, and we'll go through those and see how those building blocks build up towards this secure self-service workflow. Now, at HashiCorp, we see most of our customers going through a maturity journey on their way to a cloud operating model. And we see that really happen in 3 phases. And that first stage is that kind of tactical cloud adoption, where you've got individual teams starting to have some success with cloud, with automation, but not really doing it in a holistic and unified way. As you move on into the standardizing phase, this is where you start to establish that centralized cloud program. This is where the platform team comes into play, establishing common patterns, common workflows, common practices, and really bring all the teams together into a common foundation. And then finally, in the scaling phase, this is where you're now applying this operating model more broadly across all of your types of infrastructure, as well as across your entire organization. And this is where that self-service really comes into play. Another important aspect of the scaling phase is also day 2 visibility. Your job doesn't end on day 1 when you've provisioned infrastructure. So visibility into what has been provisioned, the health, drift, those sorts of things are what become really important in that scaling phase. And Terraform Cloud brings us solutions in each of these phases and helps you progress along that journey. So a quick level set on what Terraform Cloud is, in case you're not familiar with it. It is our fully managed SaaS platform where you can collaborate, standardize, and scale your Terraform provisioning workflows. It's really the quickest way to get started with a collaborative Terraform workflow for your organization. We do also offer a Terraform Enterprise, which is a self-hosted version of Terraform Cloud for those organizations who need that self-hosted option and can't necessarily consume a SaaS version. Now, Terraform Cloud does this through a whole suite of features. Just some of them include workflow automation, remote execution environment for your Terraform runs, secure and versioned state storage, role-based access controls, single sign-on, all the things you would expect of a SaaS service. Also, policy is code enforcement. We talked about guardrails, so we want to make sure those policy guardrails are in place. A whole host of external integrations that we can do. And really critical to today's self-service topic, a private registry where you can publish and make available your internal custom organization modules. So if you're familiar with the public Terraform registry, each Terraform Cloud organization has a private version of that registry. So applying that 3-stage cloud maturity model journey to some of these self-service capabilities we have, you can see we have features that map into each stage along the way. And the key thing here is you don't need to implement this all at once. You can take this as a journey and build up these building blocks one at a time, kind of just depending on the journey that you need to take. And these really are the building blocks of that self-service capability that we're demonstrating today. So we'll dive into each one of these a little bit. Starting off with projects, fairly basic concept in Terraform Cloud. It allows us to group together Terraform workspaces that are related to each other. The project becomes an attachment point for things like team permissions or role-based access controls, variable sets, so you can apply common variable values to every workspace within a project, as well as policy sets. We can attach policies to the project level to make sure they're enforced consistently for all new and existing workspaces within that project. And this is what really lets us allow development teams to self-manage their infrastructure, their workspaces, their applications within their project without impacting or having access to the rest of the organization. Next up, Wally made mention of eliminating static credentials. We do that here with a feature called dynamic provider credentials in order to get a just-in-time authentication method for Terraform runs against AWS. So we're using an OIDC workflow here. Terraform Cloud generates a unique workload identity token for each and every Terraform run that executes within your Terraform Cloud environment, exchanges this token with your IAM OIDC provider, which has been bootstrapped to trust Terraform Cloud, and in exchange, an STS token, short-lived token, is sent back to Terraform Cloud and automatically injected into the Terraform run environment to configure the provider and authenticate. So completely eliminating those static IAM keys that are long-lived, they're generally reused everywhere, so rotating them becomes a real burden. We can also scope this level of trust and the role assumption as granularly or as broadly as you need. So you can go down to the project level and have a shared role for a project, which actually enables the self-service capability. You can go down to the workspace level if you have that need. You can even go down to the plan and apply phase and have a separate, say, read-only role for plans and the read-write role for applies. And we can do this with wildcarding on the condition policy in the IAM role configurations. We also, just a few weeks ago, announced that we now also have this capability for the Kubernetes and Helm providers when used with EKS. So we can now use an OIDC workflow with an OIDC identity provider in the EKS service. Again, establish that trust relationship between Terraform Cloud and your EKS cluster. So now you can use the Kubernetes and Helm providers to provision resources into an EKS cluster using a similar OIDC workflow. We mentioned policy, guardrails, so we have policy as code features in Terraform Cloud as well. We do this through our own HashiCorp Sentinel policy as code framework, and we also support Open Policy Agent if that happens to be your policy engine of choice. And really this is about introducing those security, compliance, cost, business best practice type guardrails into each and every one of your Terraform runs. And the important thing here is that they enforce before provisioning. They happen in between the plan and apply phase, so that you make sure you're always provisioning compliant resources, getting proactive versus reactive when it comes to policy. We also have a feature called Run Tasks, and this is where we can integrate third-party services into that same workflow. Along with your custom policies, we can start to incorporate third-party services who offer security, compliance, and cost-type services or additional visibility services, and we have over 25 partner solutions that have created run task integrations. Those are discoverable on the Terraform Registry. A lot of great partnerships there that we have established. So another key element here is modules. Well, I mentioned modules being we talked about modules as the linchpin of this self-service workflow because modules are that fundamental building block of reusable Terraform code. And in a way, just like the permissions and policy guardrail features we talked about, modules in their own way are kind of an inherent guardrail because they contain your organization's best practices when it comes to how certain types of resources are consumed. And because of that, because they are widely used across your organization, making sure they're high quality and reliable becomes really critical because now the blast radius of an issue with a shared module that is being used widely across your organization becomes much, much larger. So it's very common for us to see our customers managing dozens, hundreds, on the high end, even sometimes thousands of modules in their private registry for downstream consumption within their organization. In this case, Crew's talking about how they have 150 validated and approved resources, and that's the important part. These are the validated configurations for your organizations, the one that you have approved. So when you're caught off guard by a bug or an unexpected change in a module, no one's happy. Both the user and the author are unhappy. That's where we introduce some of that friction. It's trouble tickets. It's that cycle of, no, that didn't work. Yes, that worked. Oh, you broke my infrastructure. But on the other hand, manually testing your module every time you change it is difficult. It's error prone. It's a checklist. How are you doing the same tests each and every time you change your module? So that's why over the years we've added a number of validation and testing features to Terraform. So a little walk down memory lane here, right, and on these suite of features we now have for code validation. Starting way back with version 0.13, we introduced input validations. So this is really that kind of first step of, right, never trust user input. So you can write conditions around the input values that users are supplying to your modules, just to, again, a guardrail for them to catch errors as early as possible. Then in version 1.2 a few years ago, we introduced pre and post conditions. Again, you can write custom conditions here. And this time the scope is individual resources, data sources, and outputs. And again, these are both really targeted at the consumer of the module. You as the author are baking these into the module, but they're going to generate errors and validations that are relevant to the consumer of the module, things that they can act on as they're using your module. Similar thing with checks. So earlier this year, we introduced Terraform 1.5, and we introduced a new top-level check block into Terraform. And this is where we can get more holistic validation across the infrastructure, checks, or across the configuration. Checks apply, or checks happen as the last step of the plan and apply phases. They don't block the run, but they're really meant for that more holistic functional testing after you've done a provisioning run and you want to just make sure things are looking good. Checks are also the primary way that we enable a feature in Terraform Cloud known as continuous validation. And this is where in the background we are running health assessments for you, and we're going to reevaluate those checks every time. You can configure notifications when things start failing. These health assessments are also when we do automatic drift detection in Terraform Cloud. And then finally, just about a few weeks ago, at the beginning of October, we introduced Terraform 1.6 with the new Terraform test framework. And the big difference here is, you notice the audience. The audience here is the producer. This is not a thing the consumer of the module sees. They see the net effect of it in that they get a higher quality module, but they don't actually see the tests themselves. This is a producer side thing. So this is not something that happens during the plan and apply phase. It's something you do during the development phase. So automated testing is not a new technique, right? It is something software developers have been doing for decades. So why wouldn't we do it in Terraform as well? And so that's what we've done with the Terraform test framework. It is our systematic approach to testing and really allows you to bring that traditional idea of unit and module, or unit and integration testing to your infrastructure as code. We write tests using HCL, so you do not have to learn a new language like Go or Ruby to write tests. And we execute those with a new Terraform test command. And now tests actually run plans and applies. So if you're doing an integration test, we're actually going to create those resources during the test run. And so what happens is Terraform test uses a temporary in-memory state, so we're not affecting live resources. And then we're also going to automatically clean those up at the end of the test run. That's how you can get that level of integration testing for things you can't necessarily catch during just a plan that you only know after an apply happens. So we don't have time to go real deep into the test framework here today. We have a lot of resources out on our developer site. The documentation, tutorials have all of these techniques, these testing techniques and code snippets in them. We also have some demo videos out on YouTube, along with a deep dive session I did on the Terraform test framework at HashiConf last month. That's on our YouTube channel as well. But just a quick example of what a test looks like, right? We supply variable values and provider configuration to the test because we're running actual plans and applies. And then we have a simple run block, which is where we declare the command we're going to run. In this case, it's a plan, so this is more of a unit test. And we can have many, many potential assertions, which is where you're going to write your custom conditions. And you notice, right, we have a new run block. That's new, but this is HCL. If you've written conditions for input validations, for pre and post conditions, you already know how to write assertions for tests because we're using all the same language functions in the Terraform HCL language. And then for an integration test, I would switch that command to an apply, where we're actually going to create that bucket, and now we can test things like calculated values that aren't known until after the apply. And really just, like I said, just scratching the surface of this test framework. There are a lot more techniques we can do, things like helper modules, things like expect failures, so you can validate your validations. So a lot of techniques and a lot of power in this framework. Now, it's one thing to have the framework available and to be able to write tests and be able to run tests, but the next step is to automate and make sure that we're running the tests every single time. So we have also integrated the test framework as a first-class citizen in the private registry in Terraform Cloud. So as you're publishing modules in the private registry, we're going to execute those tests for you. So just like workspace runs, the test runs are going to happen remotely. So you no longer need provider credentials on your laptop to run those tests. We can securely manage those in the Terraform Cloud environment. We're going to track the results of those tests over time, just like the workspace run history. And we can integrate this with a VCS workflow, so where they automatically run tests on a PR or a merge. You can do it from the CLI as you're developing to run ad hoc tests with the Cloud Run command, or this can be all done via the API flow, of course. Now, we do recognize, even though it's just HCL, right, it's nothing super new, but it does take some time to adopt a new framework, or you might even just not know what kinds of things you should be writing in terms of tests. So what we've also done is integrated a generated tests feature into the private registry. This is something available for Plus tier customers in Terraform Cloud. But basically, with the click of a button, we're going to use an AI-powered, specifically trained model on the Terraform test framework to get you really jump-started on writing modules. It won't be a 100% solution, but it'll give you some starting point and some ideas as far as writing tests goes. And you can do this for, once for any module in your private registry if you're on the Plus tier. And then simply copy that code out, bring it into your editor, add it to your module. So as we bring all these building blocks together, we'll shift our perspective now to the developer audience, right, and the developer experience, and some options we have to provide different developer and consumption experiences here. And really the goal, like this customer quote says, is we're really just trying to empower innovation. Let our developers innovate freely, but with those guardrails embedded into the workflow and the platform. So that is the ultimate goal here. And again, just very quickly recapping, we have these building blocks that we talked about around reducing risk and reducing that friction that we're going to now put together into these self-service workflows. So the first one I'm going to talk about is Terraform Cloud no-code provisioning. This is a native feature that we have within Terraform Cloud. And what it allows you to do is to take modules in your private registry and mark them as no-code ready. There are a few requirements around what a no-code ready module means, but ultimately it gives basically a code-free workflow to consuming those modules. Users go into the registry, they can filter for no-code modules. On the module details page, they simply click provision, and Terraform Cloud will handle taking that module and provisioning a workspace out of it into a project that the user has access to. And they don't have to interact with HCL or the Terraform command line in any way during that process. As the module publisher, you can set default values ahead of time to, again, reduce that friction of typos that might happen as users are entering the required variables. So you can give them a drop-down of acceptable values. So if they mistype US East 1, they're not going to get an error. Again, errors introduce friction, trouble tickets. So you can really put some guardrails around that. And then when we combine this with the things we talked about, like projects and policies and dynamic provider credentials, we can get that secure, compliant workflow without the user having to touch a key, right? The latest edition, a few months ago, we introduced to the no-code workflow a module upgrade pipeline for no-code workspaces. So when you do update that no-code module and publish a new version into the registry, any existing workspaces that had been provisioned off of the previous version will now get a notification in their workspace that, hey, there is a new version of this module available. And they get the opportunity to run a plan against that new version, see what impact it's going to have, and when they're ready, go ahead and upgrade their workspace to the new version of that module. Another offering I want to talk about is HCP Waypoint. So this is our newest offering here. It's currently in public beta. We really relaunched Waypoint last month at HashiConf. And HCP Waypoint is our internal developer platform product. It is a SaaS service on the HashiCorp Cloud platform, super easy to get started with. You can get started with it for free. And really what we're looking for here is to build that developer platform with that golden path that has been paved for developers. So rather than having developers actually go into Terraform Cloud, now they can go into HCP Waypoint instead. And just looking to further abstract that scaffolding and really take off the burden of having to know basically how the sausage is made of the infrastructure and give developers that easy to consume workflow. And we do that by underpinning templates, HCP Waypoint templates, with Terraform Cloud no-code modules. So the modules you already have, that you've already written, can now be consumed by HCP Waypoint templates by developers to create their applications without worrying about the details of that infrastructure. Then there's also a concept of add-ons within HCP Waypoint templates where you can provision, once you've provisioned an application from a template, you can use add-ons to bring additional application dependency infrastructure into that application as needed. And then for the third method that we're going to talk about, I'm going to hand it back to Welly.
Thank you, Dan. All right, so far we talked about two of the developer experience. We talk about no-code provisionings, and we also talk about Waypoint. The other one is AWS Service Catalog. So if you might not be familiar with AWS Service Catalog, this is a way for you to provide access to your end users, which is developers, within the AWS console, where they can provision a resource without giving them a full access to actually all permissions that needed to actually create those resources. So imagine you have these platform engineers and then the developer as well. As the platform, you create your Terraform modules and you package it as what we call the as the Service Catalog products with the Terraform Cloud type. You can have multiple products. You can have static websites, or you can have a database, or perhaps you have a ECS cluster. And then you combine those products into a portfolio. This portfolio is what you share to your developers. As part of sharing that portfolio, you can also define a constraint. This constraint is the role that will be used by the Service Catalog in order to provision the resources. And as the developers, you have access to the AWS console, and then you provision the products, and then there you go. Specific for this Service Catalog integration with Terraform Cloud, this is something that HashiCorp and AWS collaborates. We have this hub and spoke model. So imagine in here you have the spoke account. That's the end users, that's the developers. They have access to the portfolio. They go ahead and say, I do like to create a new website, perhaps. And then that will send the provision event to the hub account. In the hub account, you're going to deploy the Terraform reference engine. That Terraform reference engine runs on AWS serverless, such as step functions and Lambda. And that will communicate with the Terraform Cloud. Terraform Cloud will handle all of the Terraform workflow, including the plan and the apply. All right, we're going to see it directly in the demo, so let's go ahead and jump to the demo. So I think the first part, we're going to do a demo for the Terraform Cloud. Okay. Oh, let's see, sometimes it happens. Right.
There we go.
There we go. It just takes some time. All right. I mentioned earlier, so we're going to do the demo first for the Service Catalog. I mentioned earlier we have to have the Terraform reference engine. So this is the Terraform reference engine itself. The engine pretty much is a Terraform module provided by HashiCorp. So for the sake of this demo, I'm not going to do Terraform plan and apply and wait for this module to be deployed. In fact, I already have this Terraform module deployed for the reference engine. And the second part is you also need to have the portfolio. So I mentioned earlier, portfolio is the collection of the products. So in here, I created in Terraform a Service Catalog portfolio, and I added one product. So that product will take the artifact, which is the actual Terraform module, from an S3 buckets. So for the sake of this demo, I'm going to have a very simple website. It's a very cool website, actually. And that website is, again, another Terraform module in here. So what you're seeing right now is the Terraform definitions that I provided, where I'm creating an S3 bucket, set up the public access, and also the website configurations. So we package all of this into a Terraform, Service Catalog product for Terraform Cloud. And again, for the magic of the demo, I already run Terraform plan and apply, so we don't have to wait in this demo. All right, so we're going to look at the platform experience first. So I'm logging in now as the admin. So here I'm an admin. And if I look at my Service Catalog, there we go. That's my Service Catalog portfolio. As I mentioned earlier, inside a portfolio, you can have multiple products. In this case, I have just one product, which is the static websites. And I have multiple versions of that product. So you can create new versions and upload that versions. Now, coming back to the portfolio will have the constraint. This is the role that I'm going to use in order to launch these resources on the target accounts. So that means, like, as an end user, I don't have to give them full admin access. And the last thing I have to do, well, I have to give this access to this portfolio to the end user. So I'm going to go ahead and do that now. Grant the access. I set up another role which is going to act as the end user. So I'm going to go ahead and grant the access. There you go. All right, so now we're going to switch as the end user Service Catalog as a user. This is the developers. Developer log into the AWS console. They don't have access to things such as IAM. So if I go to maybe like an IAM, for example, I might get an error because I don't have full admin permissions on these accounts. But if I go to Service Catalog, all right. So you notice I have a very small view rather than the full complete view with admin access earlier. When I look at the products, apparently my platform team just gave me access to create this product. So say I want to test S3, I just want to learn what is S3, how to use the website configuration and everything else. I went ahead and go and select this product, and I can launch the product. Now, I mentioned earlier there's a couple versions, so I will choose the latest version because I want to check what is the latest. And what's nice about this is that the reference engine that I mentioned earlier will parse all of these Terraform modules variables and make it available in the Service Catalog console. So some of the variables has been predefined. I'm going to just say this one will be reinvent. You can also add additional tags, but the platform team actually defines some of the must-have tags. So these all required tags is already embedded in here. So I'm going to go ahead and launch the product. All right, so now it's under change. If I go to my events, I should see that it's currently being created. So what happened under the hood, if you remember the diagram earlier, the reference engine will send that request into the Terraform Cloud. So if you're new to Terraform Cloud, this is the view of the project and workspace. This is where you can find the runs. Here's the runs that I just had earlier. That's my account ID and the name of the product ID. Go ahead and look at it. So run is currently running. You can see that it's currently being queued. Now what's nice about this is that the reference engine also inject the variables. So you don't see any secret key, access key in here. What you see is that it's using the dynamic provider credential from the Terraform Cloud. So I say, use this IAM role in order to provision the resources. And the only principal that can use this role is actually the Terraform Cloud itself. So as an end user, I cannot try to assume this role. All right, so let's see. All right, so a couple seconds I was talking. The plan and apply is finished. So if I go back to my Service Catalog in here, and then see that, yep, it's now also available. So last thing I can do, let's take a look at the output and see if I can open this website. There you go. That's the HashiCorp. All right, so that's the end of the demo for the Service Catalog. Then I hand it over to you. Gonna look at the other part of the demo.
Cool. All right, so yeah, great integration there with Service Catalog. You can see the two-way interaction of the input variables and also bringing back the outputs from Terraform Cloud. I'm going to go over here our no-code option to start with. So again, kind of starting, and let's see if I can bump that size up a little bit so you can read a little better. So again, we're starting here on our projects and workspaces view, and right now I've got my platform team hat on. So what I'm going to do is set up a new project for a new team who needs to consume some infrastructure. So we'll start with that new project. We will call this one reinvent. And once we have that new project, we'll go into its settings here, and this is where we assign team access. So in this case, I'm going to give our, let's say, our DevOps team maintain permissions. So this allows them within that project to create workspaces, to manage workspaces, but not to do anything outside of the project or not to manage the project itself, just do things within the project. And this is the level of permission that is required in order to use the no-code provisioning workflow, because it does create the workspace as part of the workflow, so they need permissions to do that. So we'll give them the maintain permission here. The next thing I want to do is set up that authorization, those credentials. So we're going to use dynamic provider credentials. I've already bootstrapped that OIDC configuration between my Terraform Cloud organization and the AWS account using an IAM OIDC provider. And we have a role set up already for that. So here in my Terraform Cloud organization settings, I have a variable set with AWS dynamic provider credentials. Oops, that way. These are pushed in via environment variables that then get applied to the Terraform run. All we do is have this first variable that just says, hey, we're going to use dynamic provider credentials for the AWS provider. And then we give it the run role. So it's the ARN of the run role. If we were doing a separate role for plan and apply, we would have two environment variables, one specifying the plan role, the other one specifying the apply role. So what I'm going to do here is go ahead and apply this to that reInvent project I just created. So now that variable set will be made available to every workspace within that project. If there were any existing workspaces, they would get applied to them. Every new workspace will also inherit the variable values. And then the last thing I want to do is establish those policy guardrails. So here in our policy sets interface is where I have you would potentially have many of these policy sets depending on the needs and what you need to apply to various projects. I just have a single Sentinel policy set in here with a handful of AWS-related policy rules that I want to apply. And I'm going to do the same thing. I'm going to enforce that. We can enforce policies globally. So you might have those really broad policies that you do want to enforce across absolutely everything in your Terraform environment. More commonly, you're probably going to want to target those down a little more so we can enforce based on project or even down to individual workspaces. So I will also add that reInvent project to this policy set. So now that we've got our project with our role-based access, we've got our dynamic credentials set up, we have our policy guardrails set up, we can move on to the registry. So this is the private registry in your Terraform Cloud organization. Here's where you can publish your custom modules. You can also publish custom providers if you're developing your own Terraform providers. You can also curate public modules and providers into your private registry if you want to make a catalog of public modules that are authorized for your users to consume. What I'm going to do here is filter down to no-code ready modules. And just like the static website example Welly used, we're going to use the same module here. I have this no-code static website module. And you'll see here, first notice our integrated testing, right? So I did add some tests to this module. So right away we can see that, hey, all our tests are passing. We can view our prior test runs and see all the details about those tests. So we're happy with that. Here under the no-code provisioning is where we configure those drop-down options, where you can pre-supply those values. And we also select which version of the module is going to be the one used when we do a no-code provisioning. So now I'll change hats here, and as a consumer, all a consumer needs to do is come in here and click Provision Workspace. They're going to be presented with those variable options. All we need to do is give the workspace a name. We're going to select now, if I didn't log out and log back in as a member of that group, but a member of that DevOps group would only see the projects that they have access to here. So I'll select that reInvent project. We can give it a description, and we're going to default this to auto-apply. Again, we want that frictionless experience, so by default, a no-code workspace is going to auto-apply. You can change that to manual apply if you want to. So now as the user, I just created a workspace. We have the run kicking off. I didn't have to interact with HCL, didn't have to interact with the Terraform CLI. Importantly, I did not have to interact with a credential at all because it's already been set up for me by my platform team. And here, because we have those Sentinel policies applied, we're going to see after the plan finishes, we're going to go ahead and run those Sentinel policies automatically. And we'll see we've failed one advisory, or a few advisory policies, but we haven't failed any mandatory policies. So that run is going to proceed. If there was a failure of a mandatory policy here, that run would be halted and we would not provision that infrastructure. And just like before, once that creates, here in Terraform Cloud, we have our outputs and we have our website. Now, I think I've got time to also do the upgrade workflow. So I mentioned we have an upgrade workflow as well. If I go back here to the registry, again, kind of switching hats back to the platform team, we've got a new version of this module we're going to publish, and we want to make that one the new default for this no-code module. We'll come back to the module here. We'll configure the no-code provisioning settings, and I'm going to bump this up to version 3 of the module. And once I save that, here in the workspace, right away we have a notification that there is a new version of that module available. We can view that update. In this case, there's actually a new required input value for this version of the module. So I need to give that a value. In this case, it's just a number of days. And we're going to save that and start a plan. So this is, again, kind of running a speculative plan on what would happen if we upgraded to this new version of the module. So the workspace admin can, be confident that when they upgrade, it's not going to break anything for them. So as that plan runs, we will see well, that's just going to take a few seconds today, it seems. So anyway, what we're doing here is we're going to run a plan. The workspace admin gets the opportunity to see what the impact is going to be, what the changes are going to be based on this new version of the module. You see, in this case, it was simply that the module author has added a lifecycle configuration to the bucket. Well, that's pretty low impact. That sounds good to me. So I will choose to go ahead, confirm that, and apply that. And then in the background, Terraform Cloud is upgrading that workspace to use the new version of the module, and it's going to run and apply and get you up and current with that new version of the module. So as that's going, so that is our no-code provisioning workflow. You see, we put together projects, variable sets, dynamic provider credentials, policies, and then that consumer experience of no-code provisioning. Let's flip over now to our HCP Waypoint environment. And I'll make sure I probably got signed out here. Oh, no, good. All right, so this is, let me get into my project here. This is the HCP, the HashiCorp Cloud Platform dashboard. You see we have a number of services. A number of our products are available through the HashiCorp Cloud Platform, including Vault, Console, Packer. But we're going to go into Waypoint here. And now I've already activated Waypoint. It was as simple as going into my HCP project and clicking Activate Waypoint. And we start on the platform team side by defining templates. And these templates are where we basically give instructions to our developers. So if I edit this template, we see we only need a name. We can give it some descriptive tags, a summary, some description for our developers, some specific instructions here where you see we can kind of interpolate in the application name. We can give them links, instructions on how to consume the infrastructure once it has been provisioned. And then here is where we link this template to a no-code module in Terraform Cloud. So all of my no-code ready modules are going to appear in this drop-down here, and we're going to read in all the available versions so you can select which version the template is going to use. We do the same thing with add-ons. So those add-ons, again, are those things that you can provision into an HCP Waypoint application to bring more application dependencies into the environment. So just like the template, we have a name, we have a summary, description, the developer instructions, and we select the Terraform module that is going to represent that add-on. So again, switching hats, the developer experience, I'm going to come in here to HCP Waypoint, simply create an application. I'm going to get the menu of templates that have been predefined by my platform team. So I will select the static website template. All we need to do is give it a name. Actually, I think I had a rule on that I can't mix case. And we'll click Create Application. In the background, HCP Waypoint is reaching out to my Terraform Cloud organization, creating a workspace in the project that was defined in the template configuration. We see here from the developer point of view, we just get an indication that, hey, this is running. Might be a few minutes. Once it's done, here's your links to the website URL, the S3 console. If you, as the platform team, do give your developers access to Terraform Cloud to maybe monitor in more detail, you can click right over and we can see this run happening in Terraform Cloud. Just like before, we have Sentinel policies applied, so we can make sure those guardrails are all in place. Again, we're using dynamic provider credentials, which we've already bootstrapped, and we've already finished that apply. Oops. Immediately, we have the indication here that we have had a successful deployment, and once again, we can open up our website. And that, that developer instructions area is where you'd want to, provide some real detailed instructions to the developer on how to consume what has just been built for them, how they then take that and deploy their application into it. And then the last thing we can do here is install an add-on. So I have a few available add-ons here. In this case, I might want a friendlier domain name. I'm going to create a Route 53 record, maybe a CloudFront distribution in front of this S3 bucket, right, if we're going to actually take this to production. Uh-oh. Nope. Okay, well, that one's working. In this case, might need like a sidecar DynamoDB table, right, to interact with a website. So that's the one I'm going to provision here. We can see the instance of that add-on in this application. And if we click on it, again, we get those developer instructions that we set up in the add-on definition. And again, in Terraform Cloud, a workspace was created for that add-on, and it is now being provisioned. So that's our HCP Waypoint workflow. So 3 different workflows. The question might be, well, which one should we use? And the answer is really, it depends. It is really up to what the workflow that makes sense for your team and your developers as far as what the experience should be for them. I mentioned HCP Waypoint is in public beta. It is a relatively new product for us. Those capabilities are very much going to be evolving over time. Obviously, the AWS Service Catalog, very robust solution in AWS. So if you are already invested in Service Catalog as a self-service workflow, it's going to be very natural to use that as your self-service workflow. And then, of course, we have the native option of no-code provisioning in Terraform Cloud. So different ways to consume, all with the same guardrails around authentication, around policies. And with that, I think we will switch back to here. All right, so let's wrap up. We talked about the building blocks of a secure and efficient and compliant self-service workflow in Terraform Cloud. We have those building blocks of projects, role-based access controls, the dynamic provider credentials, policy as code, and that module testing workflow to make sure you have robust and well-tested modules available for your teams. And then on the self-service experience side, we showed you those 3 options of no-code provisioning, HCP Waypoint templates, which builds on top of no-code provisioning, as well as the AWS Service Catalog. So to learn more, definitely recommend the developer.hashicorp.com site. This is where we have all our product documentation, tutorials for all the products. Our education team does a really fantastic job with the tutorials. HashiCorp.com community is where you can go to get engaged with the community. We have our discussion forums there, as well as HashiCorp.com/product/Terraform to learn more about Terraform Cloud. You can get started with the free tier of Terraform Cloud. And like I mentioned, the HCP account and HCP Waypoint is free to use at this point as well. And with that, Thank you very much.